The next example deals with a non-monic quadratic trinomial. And non-monic means that the coefficient of the x squared is something other than 1. We've got something like, in this case, a 7, but a number in front of the x squared other than 1. When we're dealing with something like this, we need to just include one extra step in our factorization. And that is, instead of just looking at this number here to decide what our two numbers have to multiply to give, we actually look at the product of these two. That is, we go 7 times 2, that's 14, and it's going to be positive 14. And so instead of just looking for two numbers that multiply to give 2, we're looking for two numbers that multiply to give 14, positive 14. We then look at the coefficient of the x again, and still we're just looking for something that adds, two numbers that add to give positive 9. And the process from this point on is exactly the same. Looking at 14, what numbers multiply to give 14? Well, there's not many options. There's 1 and 14, and there's 2 and 7, and that's it. And since they're adding to give a positive, multiplying to give a positive, they both have to be positive or they both have to be negative. They're adding to give a positive, so we're going to assume that both of them are positive. We can see pretty clearly that 2 and 7 will multiply to give 14, and they'll add to give 9. So that's going to be our choice. Now, with non-monic quadratic trinomials, we can't just go straight ahead and write x plus 2, x plus 7. It's pretty easy to see that that's wrong, because if you were to expand that out, you'd end up with just an x times x squared, and then a bunch of other stuff. But we don't have an x squared here, we've got a 7x squared. So just sticking it straight into there is not going to be correct. We need to look at a different way of factorizing. And we're going to do the middle steps that we did up here. We're going to split that middle term into these two things that we've identified over here. So I'm going to split my 9x into a 2x and a 7x. And it actually doesn't matter what order we do the two in, it'll still work out. Now, having a look here, what's the highest common factor of this first pair? Well, it's going to be just x. I'm left with a 7x plus 2. Looking at this second one, there's actually not really any common factor at all. I can always bring a 1 out though, because 1 times anything just keeps it the same. And now we can see we've got a 7x plus 2 in each term. I can factorize that out the front. In this term I'm left with an x. In this term I'm left with a plus 1. And this is the factorized form of that quadratic trinomial.